Hello everyone. Today we shall discuss about the module 5. So in this module we shall discuss about the important question as well as answers for that. So first question is define measurement and explain the classification of measurement. So coming into the definition of measurement, measurement is a process of comparing an unknown quantity to a known standard. I mean, we know some standards which is set for a weight or a length or a height. Okay, those things are already a standard. I mean, you can say it as a standard. So comparing those things with the unknown quantity is known as measurement. So let us take an example of an apple. So when we don't know the weight of an apple, what do? We will keep it in a weighing machine. We will weigh it with respect to a 1 kg, 1 kg standard thing, so that we will come to know what is the exact weight of an apple. So this process, this is called as measurement. We are measuring the unknown quantity, is called as measurement. The process requires reliable methods and tools which must be calibrated to ensure the accuracy. So we know the quantity. We will come to know by having some tools we can ensure the accuracy. Okay, for measurement to be meaningful and universally accepted, the standard used must be accurate and commonly agreed upon. So measurement activities include detecting, sensing, manipulating data, transmitting, acquiring, controlling and analyzing various types of data such as physical, mechanical, electrical, optical and chemical. So these are the few things we use to analyze, things which we use to analyze the types of data. So as I had said you that it can be weighing machine. Okay, just an example, weighing machine, or you can also say some kind of measurement we need to do. There, what do? Physically we need to measure physical or a mechanical data type. So depending upon the data what we have, we will, according to that, we use a measuring tool to measure it. Okay, by this you will understand what do you mean by measurement. So just an example, we can't weigh a water, we can weigh an apple. Okay, uh, like that itself, uh, there are different measuring tools for different types of data. So by that we will classify the measurement. So let us look into the classification of measurement. So coming into a classification of measurement, the measurement can be classified in several ways based on different criteria. The key classification includes primary, secondary and tertiary measurement. So coming into a primary measurement, so there are three different types of measurement. This is a first method. Let me tell you, there are different way how it is being measured. The first one is primary, secondary and tertiary. So we'll discuss that and then we shall discuss few more measuring types. Coming into a primary measurement, primary measurement is nothing but a direct observation without any conversation. Example include matching two length or colors directly. So it is a direct observation. So my primary measurement is a direct observation. So you can directly it judge it. Okay, let me take, they have given an two example, like length, he is short, he is long. By looking at that itself you can judge it. As well as color, this is blue, black, that way you can judge. That is called as direct observation. So coming into a primary measurement is one that can be made by direct observation without involving any conversion of the measured quantity. In this case, The change in measured quantity stimulates a set of observes nerve endings so that the observer can see or sense the change directly. Typical example of primary measurement are the matching of two length and matching of two colors. Let us look into the secondary measurement. Secondary measurement involves one conversion such as using a thermometer where temperature changes as shown by the movement of mercury. So this is a best example. We are also measuring some temperature here. So how do you measure it? By using a thermometer, you do measure it. A secondary measurement involves only one conversion to be done on the quantity under measurement. So we use a mercury in the thermometer to check the body temperature. So this is only one conversion which is being done here. So secondary measurement requires an instrument which translates changes in desired parameter into translatory motion. A standard which is calibrated in length units equivalent to known changes in desired parameter is known as a secondary measurement. So secondary measurement means you need to understand one thing, one kind of conversion has been done on the quantity under the measurement. So this is called as secondary measurement. Next we shall look into the tertiary measurement. It involves two conversion. For example, thermocouple converts temperature to voltage which is then converted to a readable value. So we had discussed about the three types of measurement as of now: secondary, primary and tertiary. So coming into a primary, secondary and tertiary. Primary was just looking at that itself we will come to know what it is. We can judge it easily. Secondary, one type of conversion. Coming into a tertiary measurement, it involves two conversion. For example, thermocouple that converts temperature to voltage which is then converted to a readable value. This is called as tertiary measurement. So next is a second, it comes under the second type of measurement in the classification, that is a mechanical, electrical and electronic instrument. What do you mean by mechanical instrument? It uses a mechanical part to measure the quantity, that is called as mechanical instrument. For example, it includes spring balances and dial gauges. So this is a best example of mechanical measurement. Coming into an electrical instrument, so in this we measure an electrical quantity like voltage, current. Example to includes a ammeter and uh, voltmeter. These are the best example. We need to measure some current or a voltage, we use a electrical instrument. We don't come across or we use a mechanical instrument, we use a electrical instrument. So coming into a electronic instrument, we use electronic components for measurement. Example include digital multimeters and oscilloscope. So these are the instrument which we use for electronic components. Coming into a absolute and secondary instrument. Absolute instrument, it measures a quantity directly without needing a calibration against a standard. So it is absolute. It measures a quantities directly without needing a calibration against the standard. Example, mercury barometer measuring atmospheric pressure. So second one is a secondary instrument. It requires a calibration against the known standard. Example include thermocouple and pressure transducer. So the last classification of the measurement is analog and digital instrument. What do you mean by analog and digital instrument? Analog means which displays a measurement on a continuous scale. Example, it includes analog voltmeter and pressure gauge. Coming into a digital instrument, it displays a measurement as a numerical value on digital screen. Example include digital multimeter and digital thermometer. So we have discussed about the what is in this class. We had discussed about what is measurement, what are the classification of measurement, what are the types, and next we shall discuss the fundamentals of measurement. Let us look into it. There are two different types of fundamental methods of measurement. In the exam, they do ask explain the fundamental methods of measurement. So don't get confused with the classification of measurement as well as the fundamentals. Both are different. Coming into a fundamentals of measurement. So measurement is a critical aspect of engineering, science, industry. There are two primary methods for obtaining a measurement, that is a direct comparison and indirect comparison. In the direct comparison, the parameter to be measured is directly compared to a known standard, which could be primary or secondary standard. So it is direct means, as we know, it is a direct comparison. So coming into application of the direct comparison, this method is commonly used for measurement of physical dimensions such as length. Example include using a ruler to measure a length of an object. Advantages: simplicity. The process is straightforward and does not require a complex instrument. Yes, coming into a immediate results of the direct comparison, the measurements are obtained quickly without the need for additional processing. So disadvantage is limited accuracy. Human senses can only provide a rough comparison, leading to potential inaccuracy. So here in the direct comparison, we do also have a sensitivity issue. So direct comparison might not be sensitive enough for precise measurement, especially in field requiring a high accuracy. Next we shall discuss about the indirect comparison. In indirect comparison involves measuring a parameter by comparing it to a standard through a calibrated system. This often involves covering the measurement into an analogous form, such as an electrical signal, which is then processed and displayed. So like there we used to compare it directly, where here we are involving measuring a parameter by comparing it to a standard. Okay, that is why it is called as indirect comparison. So coming into an application, this method is crucial in industry where direct measurement are not feasible or practical, where we don't in the where we will not able to have do a direct measurement. We do come across a indirect comparison or indirect measurement. Example includes using a thermocouple to measure temperature or strain gauges to measure deformation. Coming into an advantages of uh, indirect measurement, it has a great accuracy. Indirect methods can achieve high accuracy through the use of calibrated system. It also have an enhanced sensitivity. The use of transducer and signal processing allows for the detection of small changes in the measured parameter. So there are few disadvantages as well in the indirect measurement or indirect comparison. Those disadvantages are it is very complexity and potential for error. The accuracy will be very less compared to a direct comparison method. Complexity, it is very complex and it requires calibration and maintenance as well. So as we know, indirect comparison has an error, and those error also require some processing stage to for the conversion. Errors can be introduced during the conversion and processing stage. In contents of mechanical measurement, in the direct comparison involves comparing the measured parameter directly with the standard. Indirect involves a system that senses and converts the measured parameter into an analog form. Uh, this is a uh, just a summary where you can understand it is directly, and here it senses and converts back to analogous form. So here uses a gauge block to measure a length. Here it uses a Dale gauge that converts a displacement into a readable output. In the context, in the processing industry, direct measurement, the measurement is directly related to the processing operation. For example, measuring the diameter of a pipe using a capillary. In the indirect measurement, the measurement is related to the process but not identical to the parameter being controlled. For example, measuring the temperature of milk to ensure bacteria elimination. Here the temperature measurement is indirectly indicates the bacterial count. So this is a best example how we use a measurement, direct measurement and indirect measurement in the industry. So in this we have discussed what is direct and what is indirect measurement. These comes under the fundamentals of measurement. Don't get confused with again with the classification and the fundamentals. So those two are different. So the next topic is input and output configuration of instrument. So you are supposed to write a diagram here. You can see the diagram. It is generalized input and output configuration. So looking at this, you can see there are three inputs which are being given and one output is taken from that. So the three inputs are S1, desired input, modified input and interfering input, and output is taken across the summing block. So here desired input means you can see we need to get some output, we are giving some input, that will be a desired input. So it is given to a S1. So modifying, if we want to modify any kind of we are modifying it in order to get some precise or some output, required output. So what do? We modify the input. So how do we modify? We will give it to a S2 and S3 block. So next, interfering input. Interfering input is given to a S4, then it is taken from that to a summing block. So let us discuss, this is a summary, we shall discuss what it is actually, how it actually works. So in this figure, it shows a generalized input and output configuration of a measuring system. Normally a measuring system is fed with the desired input from a sensor or a transducer, and an output is produced according to the value of given desired input. So what are we doing as an input? What are we using for an input? It is a sensor and a transducer. However, in some case the output has to be modified depending on the desired input, and another input is called as modifying input. So if you want any kind of input to be changed, we use a modifying input. For example, mass flow is dependent on differential pressure across a nozzle but has to be modified according to the changes in density of medium. Thus modifying input is in the form of temperature of medium would also need to be applied. In addition, there may be interfering or unwanted input also, like noise, which we decide should not affect the output. Hence, we use a interfering input. Coming into a desired input, a basic quantity for which the instrument is specifically designed and output should respond to this input. So the output could be linearly proportional to the input or follow a certain relationship symbolized by a mathematical operator S, defined as a transfer function, such that output is equal to S1 into input. So in case of nonlinear system, the transfer function is represented by an algebraic or transcendental function if the input is dynamic. Then S may be represented by differential equation. So coming into the second one, modifying input. These cause a change in input and output relationship for the desired input or interfering input. The transfer function S2 and S3 represent the specific manner in which modifying input affects S1 and S2 respectively, S1 and S3. So what do you mean by interfering input? These are unwanted signal to which the measurement system becomes unintentionally sensitive. The measuring system gives output corresponding to interfering input due to its principle of working and design. The interfering input could be generated in the system or outside due to pick up of stray signal. Environmental influence. So this is mainly due to the environmental influence. The interfering input is operated upon the transfer function S4 to provide an output in a manner as the desired input is operated upon S1. The output from the block is across S1 and S4 are connected to a summing block so that output after adding the instantaneous value is in the desired relationship with desired input. By this we shall let me quickly brief it. You need to know what is desired input, modifying input and interfering input. You need to write the block diagram properly when you are writing in the exam. The diagram carries more marks. So write the diagram properly as well as the arrow marks. So by this I shall end this video. Let us look into the few more topics in the next class. Thank you.